Okay, so hello everyone. Welcome to CivilPrep. So today we'll be discussing MentorQuest at the rate 500 in this session. The live question and answer discussion. Okay, so here we'll be looking at the various topics or questions from geomorphology. Okay, so guys, I want to give you an update. This Sunday, there will be a test on geomorphology. Okay, you need to make an account in civilprep.com. So the test will be uploaded there. Okay, so make an account. In your account, the test will be uploaded. You can write an answer. Okay, the test will be uploaded uh, by 9 a.m. in the morning, and you can write the test. The discussion for the test, it will occur around 3 p.m. Okay, so the discussion test upload, it will take place around 9 a.m. and the test discussion, which will also be live, it will take place around 3 p.m. Okay, so this will take place on Sunday. So Sunday, if we look at the date, it will be 8th of June. Okay, so guys, let's start our live discussion on question and answers. So for our first question for today for the discussion is, explain the origin and evolution of Earth's crust to its present conditions. Okay, so this question is for 15 marks. Okay, we'll have a 5-minute time. So with this time period, you can write the approach for answer. Okay, we'll discuss in 5 minutes. Now, what we are saying here that the question is on the origin and evolution of Earth's crust, which is the main key term here, and how it came to its present condition. Okay, so here we can include in the introduction part, we can write the various researches which have been done in the recent time. For example, uh, the Australian National University. Okay, so they used zircon isotopes from Pilbara-Creighton, okay, which have confirmed that the continental crust of Earth, it is as old as 4.3 billion years old. Okay, now this is one of the part which is provided by the Australian National Academy. Okay, in the similar manner, there is another we can say data which is present here with respect to NASA's InSight mission, which also says that the Earth's crustal thickness and structure uh, I can see. Hello, Priti. Welcome to the session. Okay, so we were about to start a discussion on the question. The question is here, that is, explain the origin and evolution of Earth's crust to its present condition. Okay, if you want, you can write an answer. I can wait for 5 minutes. Yeah, the question here it is, you can see here, explain the origin and evolution of Earth's crust to its present conditions. This is a 15 mark question. Okay. Okay, so you can try to write the answer. I'll wait for 5 minutes. Okay. Okay. No, you do not need to explain the nebular hypothesis theory. You need to add from the perspective of catastrophic model, non-catastrophic model. And yes, there will be a part of, we'll say that under the catastrophic model, actually we are talking about the Earth's evolution. Okay, the evolution of crust. So you need to add focus on those two aspects here. The nebular hypothesis is the previous part, that how the internal structure of the Earth has formed, that is the layered structure or the non-layered structure. Okay, so that will be explained first, and then you directly need to go to this part, that is catastrophic and non-catastrophic model. So in short, you can also write about the heterogeneous Earth accretion model, which is based on nebular hypothesis. Okay. Then after this, there is homogeneous accretion model. Okay. So it is also proposed alternatively and based on nebular hypothesis accretion model. Okay. So you can work on both these aspects also. So answer is written, Priti. Okay, take your time. Take your time.
Then uploading the answer.
Okay. 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 Let's look at the question. So, explain the origin and evolution of Earth's crust to its present condition. The Earth's crust has undergone a complex evolution since its formation around 4.6 billion years ago. Good. The process involves accretion, differentiation, tectonic activity, and internal geodynamic processes. Various theories given by geographers include planetesimal theory, okay, nebular hypothesis theory. According to nebular hypothesis theory, the gravity collapse, whatever DU's material was settled inward and become the core. Such a layered stratification structure is best explained by the nebular hypothesis theory. Okay, so this part is okay. Now moving to the next part. The two contrasting schools which explains the origin and evolution of Earth crust are catastrophic model, non-catastrophic model. So here catastrophic model proposes the Earth's crust evolved through sudden, violent, short-lived events rather than slow, gradual processes. Okay, evolution occurred in episodes of massive geophysical upheavals, support plum tectonics, super volcanic eruption, and rapid crustal reworking. Explains the episodic nature of orogenesis, mass extinction, and supercontinent cycle. Okay, the stages through which Haydn, Akin, Proterozoic, Phanerozoic. Okay, non-catastrophic model. Principle of present is key to the past. Holds that the crust evolved through slow, continuous, and uniform process. Good. Based on gradualism. Good. Changes occurred over millions of years. Emphasizes plate tectonics, seafloor spreading, sedimentation. Okay. Stages of evolution. Okay, same. The evolution of Earth's crust is best understood through synthesis of both models. A new catastrophic approach combining both in most widely accepted in model 3. Okay, very good answer is written here. Now, we'll just discuss this answer. Okay, answer is written good. Now, what we need to see here, we need to add here certain basics part that what is giving us about the confirmation that yes, the origin and evolution of Earth crust has taken place since almost 5.3 billion years ago to 5.2 billion years ago. Okay, so here we'll be seeing that the first Australian National University using the zircon isotope from Pilbara Craton. This is one of the important example which you have to add up here. Okay, where the experiment have been conducted or where the research have been conducted here. Now, moving further, the INSIGHTS mission of NASA, it has also given that the crystal thickness and structure, it has changed drastically. Okay, and this has happened because of the plate tectonic processes. Okay, so here we'll be seeing that with these conditions, we are able to analyze that yes, there is the Earth's crust has evolved, it has changed. Okay, so first we need to see at the origin part. When we look at the origin of the Earth's crust, we will be looking here at a model which is very much famous, that is uh, the nebular hypothesis model. Okay, so here there are two models under the nebular hypothesis. Now, what nebular hypothesis says in one model, that is the heterogeneous Earth's accretion. And number 2, here it is homogeneous Earth's accretion. Okay. Now, in the first part, what it is saying that this model, it was provided by Kant and Laplace. Okay, Kant and Laplace, they have provided this model. So what first model is saying here that when the accretion of the Earth's the accretion was taking place, the Earth's material. So here, during the process of accretion, what happened? The different layers, they formed simultaneously. The different layers formed simultaneously. Okay, so under this condition, what we'll be seeing that since the inception of the Earth, the crust, it did not undergo any kind of, we can say, the differentiation process, but it was formed of low density. Okay, here we have two kind of crust, that is continental crust and oceanic crust. Okay, so it has formed as per, we can see here that uh, in the heterogeneous conditions during the process of accretion itself. But what homogeneous model says that, it says that when the Earth was formed, it was completely homogeneous in its composition. Okay, so it was homogeneous in composition. And second thing here will be seeing that no layered structure. Therefore, no crust was present during this period. So what happened later? Later we see that there was density differentiation process. Okay, so under the density differentiation process, what happened? The layering of the Earth's crust or Earth structure, it started to occur. For example, the inner core, it become heaviest. Then there is outer core. Then there is mantle layer. And there is the crust, it started to form over the surface. Okay, so because of the cooling, okay, the crust, it formed. Now, this is the second part where we see that the crust formation, how it is, okay, how the crust is formed here, it is explained here. Now, following this process only, the third model was introduced here, that is the catastrophic model. Okay, so catastrophic model, it followed the initial postulates of homogeneous model. Okay, and under the homogeneous model, there is formation of Earth like this, and there is layered structure. Okay, and there is formation of first crust, that is the oceanic crust. Okay, so this oceanic crust, it formed around 4.2 to 4.3 billion years ago. Okay, so this thing was confirmed under the catastrophic model. Now, after this, what this theory says that Earth's surface, it was bombarded was bombarded with asteroids and meteors or meteorites. So when this thing occurred, okay, when there was bombardment has occurred in the same phase, what happened next? The Earth's outer layer, okay, for example, this is the bombardment. So this result into the violent explosion. This resulted into the violent explosion over the Earth's surface. Now, when this violent explosion has taken place over the Earth's surface, as a meteorite has impacted a region, okay, as the meteorite has impacted a region, the region's surface material, okay, actually which actually varied from 10 to 30 kilometers, it was completely evaporized. It was evaporized due to the heat. Okay, so this complete region, it was vaporized. And here what we see that there was this is the magma region, this is the magma chamber. Okay, we can also call it as asthenosphere. So there was emplacement of magma later on. Okay, so here what we see that there is emplacement of magma, and because of the emplacement of magma, here what we see that there is two structures formed here. Number one, the first structure, it is gneiss. Okay, and the second structure here, it is basaltic. Okay, so here we see that because of this, we when a large number of collisions have taken place over the Earth's crust, this has resulted into the formation of a continental nuclei. Okay, there was formation of continental nuclei, which was surrounded by oceanic crust. Now, when we are able to explain the formation of continental nuclei, we are able to differentiate two things, that is the formation of continental crust and formation of oceanic crust. Okay, so in this way, the catastrophic model, it was able to explain the formation of earth crust, but catastrophic model was not able to explain that how the further evolution of the crust has taken place. Okay, how the further evolution of Earth's crust has taken place, this was not explained by the catastrophic model. So to explain this particular aspect here, there was a non-catastrophic model. Okay, there comes the non-catastrophic model. Under the non-catastrophic model, things are taken in the similar manner. Number one, the homogeneous accretion model. Then further we'll be seeing that there was catastrophic part where there is a meteorite impact. Okay, so these things were taken up here. After this, what happened that when this model was being taken up further, here we see that this model, first it was able to explain, okay, I'm writing here, the formation of oceanic crust. Then number two, the formation of continental nuclei. Okay, after continental nuclei, there was formation of continental cratons. Okay, so here we'll be seeing that there was formation of continental cratons. Now, continental cratons, for example, over the Earth's surface, this is one continental nuclei, this is another continental nuclei, this is third continental nuclei, and this is fourth continental nuclei. So because of the convergence between them, they got stuck and they got fixed with each other. they got fixed with one another. This resulted into the formation of cratons. Okay, this resulted into the formation of cratons, and this also resulted into the formation of present day continents. Okay, we can see here the present day continents, they are almost 4.3 to 3.8 billion years old. So this thing is supported by what we can see here, the non-catastrophic model, the continental cratons here. After this, what happened? There was further, we can see there was further bombardment of meteorites. Number one. Number two, there was a second thing, that is accretion, that is denudation of landforms. And we will see that there was third thing, there was deposition of sediments. This resulted into the formation of various landforms. Okay, this resulted in the formation of various landforms. Fourth thing, what happened here? The continental, sorry, first we need to write the oceanic part. The oceanic crust, it became more denser because of its dense material plus deposition of sediments. Okay, so because of these conditions, what we see here, that it resulted into a new cycle which is called as a plate tectonic cycle. So under the plate tectonic cycle, it resulted into the movement of continental plates, and it also resulted into the movement of oceanic plates. Okay, so with the movement of continental plates, here we see that the various cratons, they resulted into the formation of supercontinents. For example, we have number one, Rodinia. Number two, we have Pangaea, etc. So these are the certain supercontinents which have formed in the recent past. Then oceanic plates, we see that currently we have one of the super ocean, that is Pacific Ocean. Before that we have Tethys Sea. Before Tethys Sea we have Panthalsa. Okay, currently we also have the remnants of Tethys Sea, they are Pacific plate. Actually it is Panthalsa, the Pacific Ocean. Okay, so this is one thing which we can understand by the starting of the plate tectonic cycle here, with the movement of continental plates and oceanic plate. Okay, so under the continental plate tectonics, we have all the three motions, that is convergence, divergence, and transform. Okay, convergence, divergence motion, and transform motion within the boundaries. Okay, so under this condition, we are able to assess that there is evolution of plates and evolution of crust have started here. Now, after this, we need to provide certain cases here for the evolution of current landform. For example, the opening of, we can say, Indian Ocean. Number two, the opening of Atlantic Ocean. Number three, We can also add up here the Tethys Sea shrinking and currently Mediterranean Sea as its remnant. Okay, so with this part, we are able to explain that how this oceanic crust, continental crust, they have resulted into the formation of the current, we can say the current crustal part here. Now, when we look at the timeline, okay, timeline you have already provided. So here we have number one, head-on ion, okay, which almost varied from 4.6 to 4.0 billion years ago. Okay, here where we see that the formation of crust plus oceans have started here. Number two, Archean, which spanned from 4 billion years ago to 2.5 billion years ago. Okay, so here there was formation of continental nuclei, okay, cratons, and here it started the formation of, we can say, the supercontinent. Okay, but it was the phase of Proterozoic eon. Which spanned between 2.5 billion years ago to 541 million years ago. Okay, so this was initiated. So after this, we see that this resulted into the emergence of large landmass and the first supercontinent cycles. Okay, for example, Rodinia. Before Rodinia, there was Columbia. After Rodinia, there was Pangaea. So this was a cycle of, we can say, the supercontinent cycle here. Okay, then crustal evolution, we have already seen here that how the crustal evolution has taken place. So here we are able to explain this part. So in the contemporary time, that is the present time, it is mostly the plate tectonics theory. Okay, number one. Number two, isostasy. Okay, isostasy which resulted into the starting of plate tectonics. Okay, number three, we can also add up here the part of the supercontinent cycle. Okay, number four, we can add up here formation of new oceans. New oceans, we have Atlantic, we have Indian Ocean, then we have Red Sea, etc. Then there is also closing of old oceans, like we have Pacific Ocean, which is closing now. Okay, and rest of the oceans, they are expanding. Okay, number six, which is quite important here, for example, the rifting of East Africa, which is resulting into the formation of new ocean. Okay, this is predicted at after 10 million years. The East African valley, it will be completely rifted, and there will be a new ocean will be formed there. It is yet to be named. Okay, in coming time it will be named there. Okay, so this thing we can see here, this has resulted into the formation of various aspects. Now, number 7, here we can also add mountains which have occurred, which have formed because of the movement of plates like Himalayas, okay, Appalachians, Ural, then we have Alps, Rockies, etc. Okay, other type of mountain, these are fold mountain. We also have fault or block mountain like Black Forest, Vosges, Western Ghats, etc. Okay, so we can see here that uh, the origin and evolution of Earth's crust can be understood with various models with their evolving timelines, and yes, it helps us to predict the uh, it helps us to predict the further evolution of Earth's crust. So by this note, we can add up this and we can end this uh, answer here. Okay. So Prati, are you able to get what we have just discussed? Okay. So any doubt, any question you want to ask? Okay. Shall we move further then? If there is no doubt. Okay. Let's move further. So I have next question here. The question is with respect to the geomagnetism. Okay, so question is discuss the mechanism of Earth's geomagnetic field generation. Okay, and evaluate the causes and consequences of geomagnetic reversals. Okay, so this is the question. You can take 5 to 7 minutes, make an approach, write the answer. Okay, then we will evaluate it and discuss it further.
क्या आने वाला है?
Done, Preeti? Okay.
मेरे को
Not uploaded.
Okay. Okay. Discuss the mechanism of Earth's geomagnetic field generation and evaluate the causes and consequences of geomagnetic reversal. Okay. Crucial component like geophysical system, solar radiation, plate tectonics, navigation, and atmospheric dynamics. Okay. Okay, geodynamic theory, convective field motion in the liquid outer core. Iron nickel light elements generate electric currents. Okay. Helical motions. Okay. Some positive feedback motion generates currents, magnetic field, flow motion, satellite data, small mission. Okay, circular variation of the field. Stabilities in core dynamics, asymmetric core metal interaction, from activity changes in Earth's rotation. Okay. Here we have consequences, biological implications, temperature weakening of the field, reversal, solar radiation, exposure possibly. Okay. Affecting species sensitive to radiation, geophysical and geological implications. Okay. Atmospheric and technological applications. Decoupled during reversal. Sunrise at lower latitudes, radiation exposure for astronauts and polar flights. Technologies. Insights into Earth's interval processes. Okay. Okay, so I have seen the answer. Answer is quite good, Priti. I need a few things here which is needed to be added up. So we will just discuss this answer. Okay. Because we have added up a lot of things here, which is quite required from the first section. But we need to add certain basic parts here with respect to development of geomagnetic field. Okay. Okay. When we talk about the geomagnetism, okay, geomagnetism, we will be defining this in a very short part. In a very short part, a definition is needed. What you have written, that is also suffice here. Okay. Now, further, what we need to say here that what is how this geomagnetic field it is getting originated. We need to talk a bit about on this particular manner. Okay, so when we are looking at the origin of the geomagnetic field, we will see here that we have crust, mantle, outer core. Okay, inner core and outer core. So this is inner core, this is outer core, this is mantle. Okay, the outer core, it is basically liquid in nature, and the inner core, it is solid in nature. Okay, besides this, what we'll be seeing that we have a three-layered structure where we have this outer core, this is inner core, and this is mantle layer. Now, what is happening in this particular part here? There are three important phenomena are occurring. Okay, with respect to the origin. Number one, what we will see here that the heat, okay, the heat which is present in the outer core, it is getting transferred into the mantle layer, because of which the outer core, it is getting cooled up, okay, and the mantle layer, it is getting heated. So this is one of the part because of which there is a convection current motion is taking place between the outer core and the mantle layer. Okay, so here we'll be seeing that there is the origin of convection current is taking place. Okay, this is the first part. This is mantle layer and this is outer core layer. Second thing, what is happening here, that is inside there is crystallization. There is crystallization of iron, that is solidification. It is taking place. It is taking place inside the outer core and inner core boundary. Because of which, what we are seeing that the lighter material like silica, okay, then we have silica is there, then oxygen, hydrogen, etc. Other gases, they are moving towards mantle layer. If you visualize this part here, this is inner core and this is outer core. So here what we will see that there is crystallization is taking place. It is continuously taking place. Okay. So because of this, what is happening here in the outer core part, there is movement of this current is taking place towards the outer part. And here the crystallization of iron is taking place. So because of this also, what we are saying that there is motion, or we can say here there is convection currents are generated. The convection currents are generated here. Third thing, what is important? Third is Coriolis force. Okay, Coriolis force, as we know that this is equator, so it is acting towards from sorry, it is acting from west to east. Okay, so it is westerly in nature. It is acting from west to east because the rotation of Earth is from west to east. So here there is presence of Coriolis force, and because of this force, it is acting on this outer core, helping in the rotation of the core. So because of these three factors, what we are seeing that the demand of the question, what we are trying to understand, the mechanism of Earth's geomagnetic field generation. The geomagnetic field generation, how the geomagnetic field is generated. Now, we are able to specify here that because of what conditions, number one, we can say that the formation of the convection currents and the rotation of the core is taking place. Now, the most important thing, the outer core, it is very heated. The temperature here, it is almost around 6,000 degrees Celsius. Okay, almost around 6,000 degrees Celsius. The pressure is also very high, because of which this particular outer core, it is in liquid state, and here it is consisting of large amount of ions because of the process of ionization, and these ions, they are getting rotated. Okay, they are getting rotated because of the above three conditions which we have seen above. So because of its rotation, what we are seeing that it is resulting into the generation of electromagnetic currents. These electromagnetic currents, they are resulting into the formation of geomagnetic field. Okay, this is resulting into the formation of geomagnetic field. Now here we are able to explain that how the generation of the electric current and the geomagnetic field is taking place inside the Earth's core. Now, the second part of the question, evaluate the causes and consequences of geomagnetic reversal. See, geomagnetic reversal, you have already talked about here. Okay, so I don't think very highly it is needed to be explained. So there is a part here that is the variability in geomagnetism. Under the variability of geomagnetism, there is one part that is magnetic reversal. Okay, the concept for this magnetic reversal, it is given by Brunus and Matuyama. Okay, Brunus and Matuyama, they have given the part for the geomagnetic reversal. Now, when we look at a particular case for the geomagnetic reversal, here we will see that a report is being given by World Magnetic Model in the year of 2020. They have said that the North Pole, okay, the North Pole magnetic dip is moving with a rate of 41 kilometers per year. Okay, it is moving with a 41 kilometers per year, while the South Pole dip, it is moving by almost 9 kilometers per year. Okay, so here we are saying that there is this particular conditions, these two conditions, this is resulting into geomagnetic reversal. Okay, this is resulting into the geomagnetic reversal, and they have specified a time period that one reversal it almost takes place in 7,80,000 years. So within this time frame, the reversal in geomagnetic field occurs. Okay. Now, when we look at one of the part here that approximately 41,000 years ago, the Earth experienced a short-lived geomagnetic reversal. A short-term geomagnetic reversal, and this phenomena it is called as the Lashchamp excursion. Lashchamp excursion, that is the sudden reversal in the geomagnetic field which have taken place. Okay, so in this part we are able to see here that how the geomagnetic reversal is taking place. Now, what are the impact of geomagnetic reversal? Okay, so impact in terms of causes we have already seen. What are the causes of geomagnetic reversal? Okay, causes we need to look at. Causes we have not discussed yet with respect to geomagnetic reversal. Causes here, the first thing is there is motion of the plate. The plates, they are moving from mantle layer to outer core to inner core. Number one, when the plates they enter the outer core. So here what happens? There is slowing of geomagnetic rotation. Okay, but when these plates they enter the inner core. Okay, when they enter the inner core part, this results into the reversal of geomagnetic field, or reversal part is quite important here because it is basically hampering the motion of the inner core and the outer core. Okay, so this outer core and inner core, they are basically hampered and it results into the changing of the we can say direction, and this results into geomagnetic reversal. Now, after this we see the consequences. The consequences you have written very well. For example, biodiversity, like all birds, penguins, turtles, in fact, various animals, when they are born, they have inscription of geomagnet inside their brain, and which helps them to navigate, for example, transcontinental birds, then turtles, which lay eggs at same site where they are born. Okay, so this is one important part with respect to biodiversity. Second thing, there will be disruption in satellite and communication system. Okay, this will also result into the certain impact on the we can say the magnetosphere of Earth. It will also impact, we can say, the magnetosphere of Earth, due to which the solar flares can enter Earth's atmosphere. Okay, apart from this, we'll be seeing that there will be various other variations with respect to uh, the atmospheric composition, okay, which will be altered because of the increased or decreased ultraviolet radiations. Okay, so these are certain things which we can see as a part of consequences. Then there is conclusion. Okay, under the conclusion, we'll be seeing that the geomagnetic reversal, the geomagnetic origin, okay, and reversal is a natural phenomenon occurring since density differentiation of Earth's interior. However, the variation or their variation have various impact over life on planet Earth. Thus, their understanding is important to sustain life on Earth. Okay, so this can be the answer which we can write here, including the various aspects from the origin of geomagnetic field, up to the convection currents, how they are being formed, then variability in geomagnetism, then causes of reversal, consequences of reversal, and the conclusion. Okay, so are you able to understand, Prati? Okay, so that's a good part. So how are you able to interpret these classes? Like how much it is helping you for answer writing and understanding the concepts? Okay, that's good. So can you feel your confidence boost up with respect to answer writing? Okay, that's great. That's great. Okay. So Priti, what we'll do here, we'll be concluding this session now because I have another session to take. So we will continue tomorrow, and a we will have classes tomorrow, and I'll be sharing a schedule because on Sunday we'll be having a test on geomorphology. So you also need to appear for the test for the geomorphology part. So you already have an account. So I'll be uploading test by 9 a.m. in the morning. So we'll be having discussion at 3. So whatever time you get, you write the answers. Okay. Then we'll have discussion over it. Okay. Okay, Priti. So I'll take the leave now. See you tomorrow. All the best and take care.